Good day mga ka-physics! Have you ever wondered why a passenger tends to move forward when a car suddenly stops? Why sports cars are made of light materials? And why gases from rocket engines drive the rocket forward? Well, these are just a few or simple questions for Isaac Newton. Isaac Newton is a well-known scientist for his theories. He formulated the law of universal gravitation, invented calculus, extended Galileo's work, and most importantly, he formulated the three fundamental laws of motion. Now let's find out what does the three laws state through the different activities that we will show. The first law is the law of inertia. This states that a body at rest will remain at rest, and a body in motion will remain in motion unless acted upon by an imbalanced force.
There's nothing more fun than popping a water balloon this hot summer day. Let's pop this balloon using this needle.
These things are at rest but still have inertia. Once the needle presses the elastic balloon, we can observe it swiftly leap upward. However, it seems as though the water is suspended in mid-air. Once the water realizes the balloon is gone, it falls to the ground because of gravity. Now let's proceed to the next activity.
Spinning a cup of water sounds like a recipe for a mess, but not when you understand the physics behind this trick. Now I have here the centripetal force and a cup of water. Now I will put it here. Will the water drop if I rotate or swing this centripetal force? Well, let's find out.
Wow, how did it happen? Well, according to Newton's first law of motion, objects in motion tend to remain in motion unless acted upon by an external force. In this case, Newton's law requires the water to continue moving along a tangent to the circle. Thus, a force is required to keep it always turning toward the center of the circle. Even when the water is at the top of the circle, the force continues to accelerate the water downwards in a circular pattern, keeping it from spilling down on your head. The second law is the law of acceleration. It states that the acceleration of a body is directly proportional to its net force and inversely proportional to its mass.
We have two bubbles here. One of them is 200 ml.
And one of them is 230 ml.
We're going to put this on the top and let go of them at the same time. What do you think will happen? Do you think the 500 ml will accelerate the largest or the second one? Or the same, both of them will have the same acceleration? Well, let's find out.
And the winner is the 500 ml bottle. Well, Newton's second law of motion states that the acceleration of an object is directly proportional to its net force. In this activity, the 230 ml bottle and the 500 ml bottle have the same mass but different force being of their weight. Force equals net weight, meaning that force is affected by their weight. The 500 ml bottle will give a much higher force than the 230 ml bottle, which means a faster acceleration for the 500 ml bottle, which will be the reason it reaches the end first.
This time, we will try to see if when we drop these two bottles with the same volume from a different heights, will have the same deformities or not. I-discovery time na!
When an object is thrown from a certain height, the gravitational pull of the Earth helps it to develop acceleration. The acceleration increases as the object advances towards the Earth. According to Newton's second law of motion, the acceleration developed by a body is directly proportional to the force. When the object hits the ground, the impact force comes into action. This is the reason why a bottle thrown from a greater height suffers more deformity than the situation where the same object is thrown from a comparatively shorter height.
And we are down to the third law, that is the law of interaction. And it states that for every action, there is an equal or opposite reaction. This is our balloon-powered car. What we're gonna do is to inflate the balloon, put it down, and release. But think again, will the balloon move the car? Will the car move? Well, let's find out.
Wow, how did it happen? Well, the air from inside the balloon pushes against the outside air. Then, the air outside also pushes back, which results the car to move forward.
Now this is our balloon rocket experiment. We'll try to let go of the balloon and watch it move along the string. It's discovery time now.
As you can see, as the gas is released from the balloon, it pushes against the outside air, and the outside air pushes back. As a result, the rocket is propelled forward by the opposing force. This opposing force is thrust.
That concludes our activities for today. So those activities shows the 3 laws of motion by Isaac Newton. First is the law of inertia, where it states that an object at rest will remain at rest, and an object in motion will remain in motion unless an external force is acted upon it. Next is the law of acceleration. An object with a greater mass will move slower, while an object with a lesser mass will move faster. And lastly is the law of interaction, where it states that in every action there is an equal and opposite reaction. We hope that you enjoyed our activities for today. See you again next time. Bye!